Hello guys, welcome back to my channel, and if you're new here on this channel, I'll be doing IGCSE physics related content. So I'll be doing past papers, topic questions, and overall revision. And if you have your exams coming up this October, make sure to subscribe because I'll be posting more videos on for that exam. So for today's video, I will be doing IGCSE physics paper 4 for the May June 2023 series. So let's start with the first question. Question 1 asks, figure 1.1 shows a balloon filled with helium gas. The mass of the balloon is 120 kgs. Calculate the weight of the balloon. So we know that weight is equals to mass times gravity. So it's basically 120 times 10, which equals 1200. So it would be 1200 newtons. The second one, the resultant force on the balloon is 54 newtons. Show that the acceleration of the balloon is 0.45 meters per second squared. So now we use the force formula. So force is equals to mass times acceleration, and we have the force, which is 54 newtons, and we have the mass, which is 120 kilograms, and then the acceleration is going to be, let's label it as A because it's a show that question. So now we divide both sides by 120, and then that would give us acceleration would be equals to 0.45 meters per second squared. So we have proved it. Part C. The balloon accelerates upwards from rest at 0.45 meters per second squared for 8 seconds. Calculate the velocity of the balloon after 8 seconds. So on this question, we're given the acceleration and the time, and we're asked to find the velocity. So we know that acceleration is equals to v minus u over t. And to find, we know that u is 0 because it starts from rest. So that means acceleration would be equals to v over t. And then v would be equals to acceleration times time. So to find the velocity, it would be 0.45 times 8 seconds. So we have the velocity of 3.6 meters per second. Part D. Calculate the distance traveled by the balloon in the first 8 seconds. So we know that speed equals to distance over time. So the distance would be equals to vt. So we have the velocity from the previous question, which is 3.6 times the time, which is 8 seconds. But over here we have to be careful because we cannot use just 3.6 over here, because from the previous question we know that we have a balloon and then it accelerated upwards to a final speed of 3.6 meters per second and from initial speed of 0 meters per second. So now we know that the speed over here is not constant. So what we have to do is take the average speed. So it would be v minus u, v plus u over 2. So since 36 plus 2, plus 0 over 2, which equals to 1.8. So we do 36 over 2 times 8. So that would become 1.8 times 8. So that would give us a final answer of 14.4 meters. That's going to be our final answer. Question 2. Define pressure. So pressure is the force per unit area. Per unit area. That's why the formula of pressure is going to be force over area. Describe the pressure in a liquid, how a pressure in liquid varies with its depth and with density. So first, let's look at the formula of pressure in liquid. So pressure in liquid is density times gravity times height. So with depth, as the depth increases, the pressure also increases because it's just multiplication. So as depth increases, pressure increases too. And with density, it's the same one. So if we have if the density increases, the other numbers would be multiplied by a higher number. So that means the pressure also increases. So it will increase with density. B. State two energy resources for which the sun is not the main source of. So most of energy sources in the earth is from the sun. So the specific ones which are not from the sun is one of them is nuclear energy. Nuclear energy, because nuclear energy is formed when two atoms they fuse together and they release energy, or one atom is hit by a fast moving neutron. That's how the nuclear energy is created. The next one is geothermal. Geothermal energy uses heat from underground due to pressure to produce electricity. And the other one could also be tidal energy. So we have three of them. Part C. State and explain whether each of the following method of electrical power generation is renewable. So renewable basically refers to it being easily replaceable. So power generation in nuclear power station. Now this is not renewable. So this is because the nuclear fuel is going to be used up. Fuel will be used up and it cannot easily be replaced. Easily be replaced. And the second one is power generation from waves in a sea. So this is definitely renewable because there's going to be multiple waves coming at the power generation. So the explanation could be there will be more waves generated. It's a natural process. So that's our answer. Question 3. State which state of matter, solid, liquid, or gas, has the greatest thermal expansion and which has the least. So the greatest expansion is gas and the least expansion is solids. So we know that in gas the particles are far apart from each other and there's weak intermolecular forces. So they could easily move away from each other when a small amount of heat is applied. But for solids, they're very close to each other. And they have strong intermolecular forces. So they would require a higher amount of energy to move them farther from each other. Part 2. Describe in terms of the motion and arrangement in particles the structure of solids and gases. So for solids, the movement is going to be just vibration. And for gases, the movement is going to be they move freely at high speeds. But they also ask that about their arrangement. So arrangement for the solid, they're going to be closely fixed in with each other. So they're going to be close to each other. Now this is a 3 marks question, so we can just stop there. But then if we wanted the arrangement for gases, is they're arranged randomly. So we can just write randomly. That's going to be our answer. Define specific heat capacity. So specific heat capacity is the energy which is required to raise the temperature of a 1 kilogram, to raise temperature of 1 kilogram by 1 degree Celsius. That's the specific heat capacity. Part 2. A student carries out an experiment to determine the specific heat capacity of a metal. A cylinder of metal is heated by a 12-watt electrical heater. State the readings that the student takes. So to determine which measurement the student takes, first let's look at the formula. So Q, representing energy, is mass times specific heat capacity, which is represented by C, times the change in temperature. So now we need these quantities to find the specific heat capacity: the energy, the mass, and the temperature. So to find the change in temperature, we need the initial and final temperature, and then we can just subtract them. Temperature. Second one, we need the mass. The last one is going to be a bit tricky, but then we need a way to find the energy somehow, and then they've given us the power. So when you look at the power formula, power is equals to energy transferred over time. So if we want to know the energy and we already have the power, that means we need the time. And then if we have the time, we can just calculate the energy by rearranging this formula. So the next one is going to be the time. So these are the 3 things the student needs. Question 4. Figure 4.1 is an incomplete ray diagram showing an object O and converging lens and the principal axis. The focal points of the lens are each labeled F. So these are the 2 focal points. So the first question is going to be complete the ray diagrams to draw the image formed by the lens. Label your image I. So now we just have to complete this diagram. Let me just zoom in a bit. And over here, we can see that on this right side, the 2 rays won't ever diverge, or they won't touch each other. So that means the image is going to be formed on this side on the left side of the mirror. So we just draw a dotted line, and then over here we also draw a dotted line to show that this image is going to be a virtual image. So they meet somewhere over here. So this is where the image is going to be formed. So we have to draw the image. So we just draw the image, and then we label it I. Yeah, that's what we have to do. So we can easily get this 3 marks over here. So part 2, 3 descriptions in the list. Circle 3 descriptions in the list which describes the image formed in I. So we know that it's virtual. So it's virtual and it's bigger than the original image O. So it's going to be enlarged, and it's going to be upright because the arrow is facing the same way as the first object. So it's enlarged, upright, and virtual. Part B. State the name for the defect of vision that can be corrected by a converging lens. So that one is going to be long-sightedness. Long-sightedness. The next question. Describe how a converging lens corrects the defect in eye. So how it corrects long-sightedness. So first, let's draw a diagram. So previously, without the converging lens, we have the eye over here, and this is the retina. And then the eye has its own lens. So now, long-sightedness is formed, or it's caused when let's say we have an object, O, and this image comes, and then it would be refracted, and then the image that's formed is behind the retina. So the image is behind the retina, and if the image is formed behind the retina, that means the person cannot see. The image has to be formed on the retina. So if we have a converging lens in between, and we have the lens of the eye, so we have an image O. So it would be refracted over here and also over here. So the image is going to be formed in the retina, somewhere over here. So that's how it fixes the defect. So when writing it, we can say the converging lens reduces the focal length. The focal length, or we can say that it brings the ray from the image closer before reaching the lens of the eye, like over here on the image. And the next one is so that the image is formed on the retina. Formed on the retina. We move on to the next one, number 5. Two types of electromagnetic radiation are used in glass optical fibers for high-speed broadband. State the type of electromagnetic radiation other than visible light. So they've mentioned one of them, which is used in glass optic fibers. The other one is going to be infrared. Give two reasons why these two types of electromagnetic radiation are used in glass optical fibers for high-speed broadband. The first reason is that glass is transparent to visible light and to infrared. Light and infrared. The second reason is infrared and light. They can carry high-speed data transmission. So they can carry high rates of data or information. Of data. This has the two main reasons why these two are used. Part B. The critical angle of a glass in an optical fiber is 45 degrees. Calculate the refractive index of the glass. So refractive index is equals to 1 over sine C. In this case, it's 1 over sine 45 degrees. So the answer is going to be 1.4. We write 1.4 over here. Part 2. Figure 5.1 shows an optical fiber made of glass. So it's made of glass. And on figure 5.1, draw carefully a ray of light in the fiber undergoing total internal reflection. So total internal reflection happens when the angle of incidence is greater than the critical angle. So over here, we know that critical angle is 45 degrees. So C is 45. So we have to draw the I, which is greater than 45. So on the diagram, we can draw straight lines. This is one of the incident, and then it would be reflected fully. And then we have another one, and then it would be reflected fully too. So now this angles, they all are greater than 45 degrees, all of them. Question 6. An electric heater uses a resistance wire of resistance 26 ohms. The power dissipated in the resistance is 2500 watts. Calculate the current in the resistance wire. So in this question, we're given the power, and the formula for power is VI. And we also have resistance, so we know that V is equals to IR. So now we put this into the place of V. So P is going to be I times IR. So the power is going to be I squared R. Now we just input the values. So power is 2500, which equals to I squared times 26. So divide both sides by 26, and then square root both sides. And then our I is going to be 9.8 approximately. So that's the current, 9.8 amps. B. The resistance wire of the heater has a length of 1.2 meters and a cross-sectional area of 7.9 times 10 to the power of minus 7 meters squared. A new heater is designed using a wire of the same material. We have to focus on that, with a length 1.8 and cross-sectional area of 5.8 times 10 to the power of 7. Calculate the resistance of this wire. So firstly, we know that the resistance is directly proportional to the length. So when the length increases, the resistance also increases. But now we have to know by how much. So at first it was 1.2, and then the other wire is going to be 1.8. So we just have to find the ratio. So 1.8 over 1.2, which is going to be equals to 1.5. So the first resistance, which is 26 ohms, so we do 26 times 1.5, which would give us 39 ohms. So that's the resistance. But then we also see that the cross-sectional area decreased. So we know that resistance is inversely proportional to the cross-sectional area. So when the cross-sectional area decreases, the resistance increases. So now this has decreased, so we know that the resistance is going to be increasing, but now we have to find the factor by how much it would increase. So we do 7.9 times 10 to the power of minus 7 over 5.8 times 10 to the power of minus 7. That would give 1.36. So this 39 would also be multiplied by 1.36. So 39 times 1.36 gives us 53. So the new resistance is going to be 53 ohms. Part C. The 2500 watts heater is used in a country where electricity costs $0.3 per kilowatt hour. Calculate the cost of using the heater continuously for 2 days. So we know that in 1 hour, in 1 day, there's 24 hours. So in 2 days, there's going to be 48 hours. So the cost is 0.3 per kilowatt hours. So we multiply 48 times 2,500. So 48 times 2,500. So when we multiply it, 48 times 2,500, it would give 120,000. 120,000 kilowatt hour. But then over here, we found it as watt hour. So we know that it's 0.3 per kilowatt hour. So to change this into kilowatt hour, we divide by 1000. So it's going to be 120 kilowatt hour. So it's going to be 0.3 per kilowatt hour. So we multiply 120 times 0.3. And our final answer is going to be 36. So the cost is going to be $36. Question 7. The voltage across the primary coil of a 100% efficient transformer is 220 volts, and the voltage across the secondary coil is 12 volts. The current in the secondary coil is 2.5. Calculate the current in a primary coil. So in a 100% efficient transformer, the voltage VP, the primary voltage, times the primary current is equals to the secondary voltage times the secondary current. So the primary voltage is going to be 220 volts. We don't know the primary current, so we just write it as I. And then the secondary voltage is going to be 12, and the secondary current is going to be 2.5. So we divide both sides by 12 times 2.5. 12. Oh, I made a mistake here. Let's go back. So we don't divide both sides by 12 times 2.5. We divide both sides by 220 to make I the subject. So by 220. So 12 times 2.5 over 220, that would give us 0.14 amps. So the current is going to be 0.14 amps. Part B. Calculate the ratio of the number of turns on the primary coil to the number of turns on the secondary coil of the transformer. So we know that the voltage on the primary coil over the voltage on the secondary coil is equals to the number of turns in the primary coil over the number of turns in the secondary coil. So we have these two values, so it's going to be 220 over 12, which is approximately 18. So the ratio is going to be 18 to 1. So 18 to 1. We can also just write it as 18. Either way is fine. Question number 8. During a beta decay, one of the neutrons in the nucleus changes. Yeah. State what happens to this neutron. So what happens to it is it changes into a proton and an electron. So proton and electron. Part 2. Explain how charge is conserved during this change. So we know that a neutron becomes a proton and an electron. So if that's what happens, we know that neutron has no charge. So neutron disappearing means nothing. So the first one is neutron doesn't have a charge. Have a charge. The second one is the neutron changed into a proton electron. So a proton has a +1, electron has -1. So the total charge is going to be 0. So proton has +1 and electron has -1. So the total charge will be 0 because +1 and -1, that just gives 0. Part B. Compute the nuclide equation for the alpha decay of radon 212 to form an isotope of polonium, symbol PO. So during an alpha decay, an alpha particle is formed. So an alpha particle is an A and it has a mass number of 4 and a proton number of 2. So we can write it as A, mass number of 4, proton number of 2. So now this 2 has to be equal. So if there is 212 on this side over here, the sum of the mass number should also be 212. So we have polonium, which is O, PO. And then if the alpha particle has 4, that means 212 minus 4, it would become 208 as a mass number. And 86 minus 2, it would become 84. So now the sum of the mass numbers, these two mass numbers, is 212, and the sum of the proton number is 86. So this is the same as this one. So this is the formula, but we can erase this part. We don't have to show it. That's going to be our answer. So question number 9. Figure 9.1 shows the Sun as the central dot and the planet Saturn, Jupiter, Earth labeled. So we have Saturn, Jupiter, and Earth labeled SO, JO, and EO. The planets orbit the Sun anticlockwise. From the Earth's orbit, the planets appear aligned. Assume that Saturn takes 30 years to orbit the Sun and that Jupiter takes 12 years to orbit the Sun. On figure 9.1, mark the positions of Saturn and Jupiter 5 years after the original positions shown. Label these positions S1 and J1. Show you're working. Okay, so this question is a bit tricky. So this is the Saturn, and then it takes 30 years to complete a whole circle. So we know that it goes anti-clockwise. So it takes 30 years to do a complete 360 degrees or a full circle. So 360 degrees. And we ask the position of Jupiter and Saturn and Jupiter after 5 years. So after 5 years, it would become x. So it would be 360 times 5 over 30. So that would be 360 times 5 over 30. That would give us 60 degrees. So Saturn is going to be 60 degrees from the original position. So S1 is going to be 60 degrees. So I don't have a protractor, but then this angle over here, it should be 360. I mean, it should be 60 degrees measured. So, and we have our point S1. And for Jupiter too, we do the same. Let me use another color for Jupiter. So we know that Jupiter takes 12 years. So in 12 years, it does 360 degrees, a whole circle. So that means in 5 years, it would do x. So it would be 5 times 360 over 12. So 5 times 360 over 12, that would become 150 degrees. So it would do a complete 150 degrees. So it would be somewhere around here. So this angle should be 150 degrees. And then Jupiter is going to be somewhere here. We can label this as J1. So we just have to make sure this is 150 degrees. And then for the Saturn, it's going to be 60 degrees. So for our working, we can just put this part over here. We can just put this part. Let's move on. Question B. On figure 9.1, mark the positions of Saturn and Jupiter 20 years after the original positions shown in figure 9.1. Label these positions S2 and J2. For this question, we also do the same thing we did for the previous one. So we know that Saturn takes 30 years to do a 360 degree. So after 20 years, it would become x. So it would be 360 times 20 over 30. So that would give us 240 degrees. So 240 degrees. So the new position of S2 is going to be somewhere from the center over here. So that means this whole angle over here is going to be 240 degrees. That's for S2. And then for Jupiter, we know that Jupiter takes 12 years to do 360 degrees. And then in 20 years, it would do x. So we do crisscross, and then x would be 600 degrees. So obviously this is a circle and the maximum one is 360. So we know that it does more than one revolution. So we do 600 minus 360 degrees, which becomes 240 degrees. So this is also going to be at 240 degrees. So it's going to be in the same alignment as S2. So we write J2 over here. So same alignment, which is also 240 degrees. 2. State what is observed from the Earth's orbit after 20 years. So when we go back to the diagram, we can see that after 20 years, J2 and S2 are going to be aligned. So we can just write that. So Saturn and Jupiter are aligned. So Saturn and Jupiter are aligned. C. I choose two words from the list to describe each planet. So Jupiter is going to be gaseous and large. So large and gaseous. And Earth is going to be the opposite, rocky and small. Small and rocky. Part 2. The average density of Jupiter is much less than that of Earth. The gravitational field strength at the surface of Jupiter is greater than at the surface of the Earth. Explain how these differences in density and gravitational field strength are consistent with your answers to CI. So for density, Jupiter has lower density because it's made of gas, and gas has less density than rocks or Earth, which is rocky. So has lower density because it's made of gas. And when you talk about gravitational field strength, Jupiter's is larger because Jupiter is bigger and it has higher gravitational field strength, and because it has more mass. It has more mass, and it's larger. That's gonna be our answer. Part D. The average density of Jupiter is 1,300 kilograms per meter cubed. The volume is 1.4 times 10 to the power 15 kilometers cubed. Calculate the mass of Jupiter. So we know that density equals mass over volume. So mass is going to be density times volume. So density is 1,300 and volume is going to be 1.4 times 10 to the power of 15. So now when we multiply this, we can put it in standard form, and then we can get 1.8 times 10 to the power of 27. That's going to be our answer. Kilograms, of course. So we can see that Jupiter has a high mass, very high mass. Number 10a, I believe this is the last question. Show that 1 light year equals 9.5 times 10 to the power of 15 meter. So we know that light year is the distance light travels in 1 year. So we have the speed formula, which is speed equals distance over time. We can rearrange this, and distance becomes speed times time. So speed of light, we know it's going to be 3 times 10 to the power of 8 meters per second. But for the time, it's going to be 1 year. But we have to convert this into second. So 1 year is the same as 365 days. So 1 year is the same as 365 days. And 365 days, in each day we have 24 hours. So 24 times 365, we have 8,760 hours in 365 days. And we know that for every hour, there's 3,600. So 1 hour is 3,600 seconds. So we multiply this by 3,600. So we would get like 31,500,000. So 31,536,000. So now we have this. So now we multiply 3 times 10 to the power of 8 times 31,536,000. So when we multiply this, we get 9.5 times 10 to the power of 15. So we have proved it. BI. State one measurement that is taken when determining the speed v at which a galaxy is moving away from the Earth. So that is going to be redshift. Because redshift is what we use to determine the speed of a galaxy moving away from the Earth. Write down the equation relating v and distance of a far galaxy. So whenever we're talking about the distance of a galaxy and the speed of a galaxy, we're talking about Hubble's constant. So Hubble's constant is going to be the speed over the distance. State how the distance of d of a far galaxy can be determined other than by using the equation in 2. So how we determine the distance of a galaxy is by the brightness of a supernova. A supernova. Supernova is one part of the life cycle of a red supergiant star. So it's around the end. So a supernova, it's what forms after a red giant has decayed. So the V in Hubble's equation is determined by redshift, and the distance is going to be by the brightness of a supernova. So if the supernova is far away, the brightness is going to be decreasing. If the supernova is closer, that means brightness would increase too. So that was the last question. If you enjoyed, make sure to like and subscribe. Or if you have any comments, questions, or suggestions, make sure to drop them down below in the comments. And thank you for watching.